Hello, and thank you for joining me again. Today I thought I'd share with you an interesting use case that was sent to me by one of my colleagues. It is a customer, a local government customer, that has multiple sites in their region. Each site facilitates different council services, like schools, public services, libraries, and so forth, hence the names that I've used on this slide. Now, each one of those is aggregated into an MPLS backbone. So links come in from different sites into a switch. Those switches, on those switches, sites are terminated on VLANs. Those VLANs are then passed up to the PE device on the MPLS backbone. It's a private MPLS backbone, by the way, which are then mapped to VRFs, and obviously from an MPLS perspective, there's any connectivity between VRFs within the same business unit, but different business units cannot communicate with each other except via an external routing device, which is typically a firewall. Now, this all works fine, but this equipment is coming end of life, and the customer is looking at ways they can optimize. Right? And one of the ways they can optimize is to get rid of multiple components. So we've discussed before, or rather I've discussed before in my different videos, that a FortiGate is not simply a firewall. It is a multifunctional security platform. It can be a router. It can be multiple routers via the VDOMs. It supports BGP, ISIS, RIP, OSPF. It supports dual stack, IPv4, IPv6. It can be a controller for switches, access points. So it can create an entire network managed from a single IP address. But one of the things it doesn't do is MPLS. So how do we get around this? The customer would like to keep the same model of separation, but with all the benefits of the simplification via consolidation. So the solution that we can provide to this customer is to leverage EVPNs. Now, the EVPN will do functionally exactly what the MPLS is doing today, except that instead of using layer 3 between the VRFs, it is going to be using layer 2 extensions. So this is more analogous to an old MPLS VPLS environment where you're using private wire services. Okay, so in our world, all those routers, switches, and so forth disappear. We take a single FortiGate. Obviously, it'll be a HA cluster of FortiGates for resilience, but let's consider it as a single entity. We take that FortiGate and we subdivide it into different virtual firewalls. Now, what's the benefit of a virtual firewall over a VRF? A VRF is just a separate routing table. There is no real security unless you consider security by obscurity to be security. But in my opinion, that's a very 1990s view of security. A virtual firewall or a VDOM, they have all the capabilities of the physical firewall. So they've got all their policies, rules, NGFW capabilities, application control, IPS, antivirus, anti-spam, anti-phishing, all that stuff, all right? So now, all the sites that from externally, all their downstream schools and libraries and whatnot, that terminate into any one of these sub-regional hubs will land in their own virtual firewall and will inherit the securities specific to those. Then what we do is we interconnect each one of these VDOMs to a WAN VDOM. So that WAN VDOM is going to communicate via the fiber optic, their private fiber optic backbone, to each other. We're going to run multi-protocol BGP and with extensions, EVPN extensions. So for each individual business unit, they will get their own layer 2 domain. Each one of the subtended VDOMs will then interconnect into the WAN via a point-to-point VXLAN, which is then bridged onto the backbone EVPN. So imagine this was a Windows PC, this was a switch, and these were backbone switch ports. This would be the analogous to the Cat5 cable coming in from the Windows machine plugging into a switch onto a VLAN, and that VLAN would be carried across the other switches via the switch trunks. So that's a high level analogy, but hopefully you get the picture. And exactly the same happens. So anyone on the pub network can communicate with anyone else on a pub network irrespective of site. Same with edu, same with library. Now, when these wish to communicate out to the internet or communicate between each other, they would then come up to a transit VDOM, what I've called here the INT or Internet VDOM. And this also has a VXLAN tunnel per business unit, hence the color coordination here, right? Red for library, blue for edu, and I haven't actually shown the black for pub, but I'm sure you can fill in the gaps there, all right? And you can see here that I've given each their own unique VNI, and I've given each business unit their own /16 here, so that we can subdivide them and keep their layer 3 networks unique. They will be unique anyway, but so that we can identify what's what from a management perspective. So the analogy of operation here is very simple. It would be the same as if each one of these VDOMs were individual routers connecting to a central switch. When they get to that central switch, they are provided ports on dedicated VLANs per business unit. So the red VLAN, the blue VLAN, the black VLAN. Any site on the same VLAN can communicate with any other site on the same VLAN, and to break out to the internet or communicate with each other, they would come up an Ethernet trunk port to a routed device here, which would then either allow inter VLAN routing or allow stuff out to the internet. So that is and as I said, the analogy of the functional capability. But obviously, it's not using a switch. It's using this EVPN backbone. So from a simplified, if I just take one of those business units, as I said, the VDOM communicates via a VXLAN, a point-to-point VXLAN. That is then bridged onto the primary EVPN. The same happens at each site. So this business unit is all on the same VNI and the same broadcast, and also in the backbone here, excuse me, I'm using OSPF so that there is full reachability. All the sites know about the LAN subnets of each other, and so that they can communicate. But again, because these are firewalls, they're no longer simply routers, we can control that communication via policies in each one of those. Right, so hopefully that was clear. Now let's go along and have a look here. I think my certificates have expired because I've kept those sessions open for too long. So let us just go back in there and refresh those. There we go. Obviously, I'm not using genuine certificates there. Okay, network interfaces, and let's close that down for a second and go to the global VDOM here. Okay, so starting off, so I've got 3 devices. I've called them SE1, SE2, SE3 for no good reason other than that's the first naming convention that popped into my head. But if we come along here, we'll see that I've taken from the pool of interfaces, I've taken 2 here on each device and I've put them into the WAN. Remember, the WAN represents the backbone. So this is where I'm going to be forming my BGP peering, and then the EVPN overlay is going to happen there. And then I've got interfaces in each one of the subtended VDOMs. So this is the device that's not only going to be supporting aggregation of business unit connectivity, but it also has the additional functionality of being the internet gateway via an internet VDOM here as well. If I come across to the next one here, can see exactly the same, but this one does not have the internet. Obviously, it's just got the 3 business units, and the same again here. All right. So let us start in the WAN VDOM, and it'll be exactly the same in all of them. So I'm not going to go into each one individually. So show a router BGP. Okay, so obviously we need BGP to carry the EVPN. So you can see here I've enabled the multi-protocol BGP. I've got my extensions here. Here's my one peer and my other peer. Because I've just got a triangle, I'm simply peering on the /30 links. In a real world environment, I would be using the loopback, and I'd be redistributing that loopback via OSPF or some other IGP. Okay, so that's the BGP side of things. Then I do a show system EVPN. So this is where I create the route descriptors, as well as what are my imports and my export route targets. Okay, from and these will be what the BGP is going to be sharing with each one of its neighbors. And then I go show system VXLAN, and here is the VXLAN. So now these are the VXLANs. These are the VNIs for the backbone. So I've called them 100, 200, and 300. And you can see here I've mapped them to the EVPN instances. Okay, so this is all the stuff that's going to be shared via BGP, and it's going to form part and parcel of the EVPN backbone. Then these are the point-to-point VNIs that I have created for each of the subtended VDOMs, library, public, and edu is down there as well. I just timed out. There it is. Okay. And remember what I said, that this box is also acting as the internet gateway. So I've also got other point-to-point VXLANs coming from the internet VDOM, coming back into the EVPN infrastructure with their own VNIs. Okay. So how do we then tie these up? Well, we tie them up using these software switches. Now, it says software switch, and obviously what I'm showing you here is a virtual machine. So it is 100% software switched on here. Virtual machine, there's no way about this. But on a FortiGate that has a SOC 5 chip or an NP7 NPU, these will be hardware accelerated. All right. So don't get hung up on the word software. The traffic, the VXLAN traffic, will get offloaded to the ASIC and hardware accelerated. All right. So you can see here that the purpose of this switch is to aggregate. Think of this like a central switch with other switches connecting in. So it's taking in the EVPN and the inter-VDOM VXLAN links, and it's bringing them all together so that they can communicate. It's creating a contained broadcast domain, and do that for all the VNIs. All right. Now, if I come along here and I do a get router info BGP EVPN network. So here I can see what's actually happening here. So here are my route distinguishers 100.1, and here are the MAC addresses that have been learned and imported from the other devices sharing that same route descriptor. Okay, so here's 200.1, and down here is 300.1. So you can see this is my EVPN backbone, and here you can see the BGP, all right, the ASs and the paths they are taking. All right, so that shows you that you know, the EVPN is doing its job there. Now, if I come along back to the internet VDOM here, if I come to my interfaces, so here is my VDOM link, and then attached to that inter-VDOM link, here are those point-to-point VXLAN tunnels I was talking about. And these will represent the default gateways for any of the devices connected as edge points, or CPEs, customer premise equipment. When they connect to the individual VDOMs, all right, what they will get in those VDOMs, if I come to the public, for example, and I look at static routes, not static routes, sorry, I'm using OSPF here. They will be getting all the routes, okay, as well as the default route, telling them how to get to the outside world if they don't know a more specific route. So there's the 200.1 that you saw. This is specific for pub. And if I go along to education, and I come along here, all right, 253.1 for that one, and it'll be 100.1 for libraries. So remember I said that Over the EVPN, the layer 2, I'm using OSPF to provide inter-business unit connectivity and reachability, as well as sharing routes on how to get to other business units, but the communication between other business units is still being arbitrated via the internet device here. So this is not only the gateway, but it's also got the policy. So here I've got a policy saying any traffic coming from any of those business units going out of port 5, which is the internet link, accept that traffic and provide security services. Here I've got web gateway, application control, apps, and certificate inspection. All right. But here, for example, I'm allowing communication between the library and the public BUs. Okay, so again, that wouldn't be able to happen, and I've even tied it down just to ICMP, so I can get highly granular in terms of what communication is allowed between different business units. So if I come along here and I go, well, first let's do an IP config, pipe 2 more. Okay, and we can see that's 1321. And if I do a trace route dash D, let's go 8.8.8.8. Okay, I can see that there's the 100.1. Okay, so that is going out the internet VDOM here. So if I come along here and I look at my inter VDOM link, so there is my gateway to the outside world over the EVPN infrastructure. Okay, same if I come along here, trace route dash D 8.8.8.8. Okay, there's my 253.1. Okay, 253.1. And lastly, if I do a trace route dash D 8.8.8.8 here. Okay, and there's my 200.1. So once again, all right, so these devices are connected to each one of the sub-tendered VDOMs on the different parts of the infrastructure, and obviously you're seeing the communication there. All right, so also here, if I ping, so I'm going to ping this device here, and this is the one that I allow through that policy. So if I switch on my Wireshark here, okay, accept that, and we go like that. Okay, so now we can see that I've got inter-subnet communication there, and again that traffic is going via the internet VDOM. So I've got any-to-any connectivity, I've got any-to-internet connectivity, and I've got any-to-any connectivity within an EVPN, VNI. I've got any-to-internet connectivity going out to the internet, and I can facilitate inter-VNI communication via this device here as well. So it was a high-level overview. Obviously, EVPNs are a bit more of a complex subject, so this was just to give you a flavor of the art of the possible. So hopefully that made sense, and I bid you farewell until the next video. Thank you very much. Bye-bye.